Welcome to MEI Mechanics. We're on the topic centre of mass, and this is video 1.3, centre of mass of a triangular lamina. Now, the key to dealing with triangular laminas is to know a little geometric theorem about where the centroid of a triangle lies. Now, if we take any line between the vertex of a triangle and the midpoint of the opposite side, that will pass through the centre of mass of the triangle. And we can convince ourselves of that if we look at this one here in respect of these horizontal lines, because this line from A to the midpoint of BC divides each of these lines in two. So wherever you are in terms of your height up the triangle, it's always got as much mass to the left of it as it has to the right along that line. So it makes sense that the centre of mass should be on one of these lines. And if we draw any two of those, or indeed all three, we can say they all pass through this single point, and that must be the centre of mass. That's all well and good, but where is that centre of mass? It's clearly not in the centre of each line, because it's clearly closer to the opposing side than it is to the vertex. But if we look carefully at this, and there are quite nice ways of convincing yourself of this if you want to go and read up on it, it turns out that it divides these lines in a ratio of 1 to 2. In other words, it is 1/3 of the way from the opposing side, or it's 2/3 of the way from the vertex. So if we're thinking about a triangle and we're thinking about it with its base, for example, aligned with the horizontal, then we can find the height of the centre of mass by going 1/3 of the way up. Alright, so this point here along this red line is 1/3 of the way along, 2/3 of the way remaining to get to A, and by thinking about these horizontal lines you can convince yourself that that means they're actually 1/3 of the way up the perpendicular height as well. Okay, let's see this applied now to some situations. Now if you're lucky, which you probably will be in an exam, you'll be given either a right angle triangle like this, with its sides, short sides aligned with the axes, or possibly an isosceles triangle like this one, again nicely aligned with the axes. So can we apply what we know from the previous slide here? Well, yes we can, because again if we put these lines on it will help us to see this. But the centre of mass is going to lie 1/3 of the way along this line from here, and 1/3 of the way along this line from here, or 1/3 of the way along this line from there. So it's there. Okay, so it's 1/3 of the way up the triangle from the base, and it's 1/3 of the way along the triangle from that left hand side. So how do I get from the origin? If I place the origin here, well, the whole width of the triangle is A, so to get as far as that I'll be doing 1/3 of A, and then to go up I'll be going up 1/3 of B. Alright, so the centre of mass there will be 1/3 A, 1/3 B. If we have a isosceles triangle, well, by symmetry we can convince ourselves quite easily that the centre of mass is going to be on this line of symmetry, so we don't need to worry about where it is horizontally. It's obviously going to be on that line, and because it's made up of two separate right angle triangles, it will still be 1/3 of the way up. In fact, it would be 1/3 of the way up any triangle, so it's definitely the case here that it's 1/3 of the way up here, so 1/3 A. So if we again call that distance B, then the coordinates of that centre of mass are going to be 1/2 B, because that's where that line of symmetry is, and 1/3 of A. Here's an example. very similar to what we've been talking about, except we've got actual numbers here. And notice the orientation of this triangle. Be careful with this. So the right angle is here, and so the position of the centre of mass is going to be a third of the way from here along. Alright, which means it's going to be 2/3 of the way from there. So the centre of mass is going to be roughly there, but we have to be careful because it's 1/3 from there. 2/3 from here, which is what we need because that's where the origin is going to be 6. So it's 6 centimeters from the y-axis, and a third of 8, so 8/3 in the y direction. Alright, so the centre of mass is simply 6 8/3. So that concludes video 1.3, centre of mass of a triangular lamina. In the next video, 1.4, we're going to look at the centre of mass of composite bodies in 2 dimensions.